My name is Chun. Today I'm presenting for the CISC614 final project. The name is One-Dimensional Election Simulation. So election simulation is a very interesting topic for everyone because it involves everyone's life. So in the two-party system in the United States, we can describe the political view of voters as quantitatively on one-dimensional line. 0 means neutral, negative means Democrats, and positive means leaning towards Republicans. Based on this, Reed in 2004 implemented the NetLogo 2.0 one-dimensional model and used it to verify the median voter theorem based on few assumptions. There is only one round of election to determine winner, and the losing candidate tries to change standpoint to attract more voters. As a result, in the long run, the two candidates are moving towards 0 and have very similar political views. This kind of diverged from our observation in the recent elections. Why is that? After some thought, I made the following hypothesis. The candidate generation process in the United States, known as the primary election, will counter the effect of median voter theorem. So I proposed the following experiments to add the primary election, and then we monitor the key metric, candidate platform near median, in the long run. Here is the methods. I will first reinventing the base model in the recent NetLogo language. Now I'll add the primary election and check the simulation results. Last but not least, I will add the voters' opinion movement and check the simulation results. First, I kind of reinventing the base model in the recent NetLogo language. With this simulation from the base model, we can observe that the candidate platform near middle is kind of 19%, which verify the median voter theorem. And after we turn on the variable information, the wins are kind of balanced between Democrats and the Republicans. Next, I'm trying to add the primary election into the process. I utilize the breed feature in NetLogo to define the Republican candidates and the Democrat candidates. For Republican, here is an example. I sprout 3 candidates and check each Republican voter's the distance against them, and only add the vote count for the closest one. After that, the one with the most votes will get picked, and the other 2 candidates will get removed. With the primary election on, the model can the candidate platform near the median gets significantly reduced to 20% after simulation. However, there is still one problem, that the cumulative wins are highly unbalanced due to the random initialization. So if the random initialization favors a Republican party in this case, the Republican will get dominant in the long run. This is inconsistent with what we observe in reality. That's why I made an additional assumption to allow the voters' opinion to move during the simulation. That random voters tend to get irritated by certain policy from the current winner and get away from them. I expect this to result in balanced win ratio from 2 parties and alternative win patterns. The implementation is quite straightforward. So if the winner is Democrats, people will move a little bit towards positive with a random float. Reversely, they will move towards the negative. With this implementation, the simulation results shows much better. I observed the balanced cumulative wins when the Democrats and Republicans are initialized with equal probability. Also, by logging the winners, I observed alternative winning patterns similar to reality. To summarize, I reinvented the base one-dimensional election model in NetLogo 2.6.2 and verified the median voter results observed in 2. Next, I added the primary election, which reduced the key metric candidate platform near median from 90% to 20%, which is consistent with our recent election reality. Last, I added the voters' opinion movement based on a hypothesis and observed alternative winning patterns, which is very close to reality. The future work with we can change the voter standpoint movement based on historical data and the survey instead of a random float. Here's the reference. Thank you.